Project 3.4.3 SAR ADC completed. So basically this is my completed circuit of the SAR ADC. So over here I have the inverter clock right here, and then this is a switch that talks it to automatic or manual mode. And over here is the this is the 273 register. This is the first one, and it gives it's like a D flip-flop to all of these. And then these are D flip-flops that go to AND. I've labeled the pins, the bits that they correspond to. So for example, this AND controls bits 6 to 3, and this AND is from 0 to 2. And over here is the output 273 register with the LED as outputs. And up here, here's the analog voltage input and the LF398 sample and hold chip, which holds it in this capacitor. And this is the comparator that compares the analog to the digital 7 bits given by the DAC. So basically, here's the sample and hold part. So if I just like estimate a voltage right here, this is around This is around 2.66 volts, and because I'm on manual mode, as stopped. So if I just switch this potentiometer, and right now, as you can see, it is lower than what it was before. So the comparator will output 0 volts, and when I switch it to be higher than what it was before, let's say around 4 volts, the comparator will output 5 volts, which is high. So when I plug the circuit into power right here, like some of the LEDs are, like these are the LEDs that are not supposed to be on, and sometimes they just flash on and off. And like when I spin it, it will like change the LEDs. And I can kind of like put it in manual mode here to see what it's supposed to be. It's supposed to be like this, and when I switch it here, as you can see, like these LEDs are the ones that are flashing, so they're not supposed to be on. And I'm not sure, it might have something to do with the wiring of this chip. But the output voltage right here that the DAC is giving is very similar value to the capacitor. And when I switch it to manual mode, it will kind of like start testing all the LEDs, and by the end it will end up with what it's supposed to be. So basically manual mode works just fine, but the automatic mode, the LEDs are not supposed to be on, just starts flickering. And when I plug a DMM here, as you can see, if I switch to automatic, so the input capacitor is around 3.2 volts, and the output from the DAC is also around there. So it is giving a pretty accurate like 8 bits from the DAC, but the output is just very finicky. And like if I turn the potentiometer, is another value, and here is a very similar value given by the DAC. So this is the timing diagram of the SAR ADC. So basically at 0 ticks right here, like the clock will give 1 pulse as seen here, and the D-type flip-flops and the AND gate will set the most significant bit to high, which gives the DAC an output of 2.5 volts. And this is compared to the analog input, which in this case is 1.74 volts. And because it's lower, the comparator outputs a signal of 0, which sets the most significant bit to low. And then the rest of the D flip-flops and the AND moves on to the next bit, and then it compares it again at the next clock tick. And by here, because 1.74 volts, the analog input is greater than the DAC output, the comparator will output a high signal, which makes the bits stay on high, and this will continue for the rest of the 5 bits left, and then it will end up with a pretty accurate like approximation of the analog voltage in 7 bits, and this will get outputted to the DAC. And then after that is over, the sample on hold will take in a new value for its capacitor on the next clock tick, which is this one, and then the cycle will repeat again where the DAC will try to approximate another value. And finally, I just want to say thank you to Mitsuru Yamada for designing this entire circuit for me to build and learn with. And he came up with this when he was 19, which is really impressive because now I'm having a lot of troubles and issues just trying to build the circuit with a circuit diagram. So I just want to give credit where it's deserved.